Okay. Remember that your test is Thursday, and there are no, we're not postponing it. We have a test on Thursday, which should give you plenty of time to be ready. So here we go. Convert to rectangular coordinates. What does that mean this is? What are these? So they are what? R and theta. And we are looking for X and Y, right? How do we find X and Y? You got little formulas you were supposed to memorize.
X equals R cosine theta.
X equals R cosine theta. So negative 2 cosine 30. Y equals negative 2 sine 30. It's that easy, right? Now, is 30 special? Yes. 17 would not be special. If that were 17, we'd type it in on our calculator, right? But what do we do since it's 30? We draw a picture of a little 30, 60, 90 triangle over here. What's the cosine? 3 over 2? So what do we end up with? What's our x coordinate?
2.
Well, those cancel, so it's negative root 3. What's the sine of 30? One half.
So it's -1.
-1. There are your rectangular coordinates. All right. Number 2 says convert to polar coordinates. All right. So what does that mean? This is if we're converting to polar, these must be what? X and Y. And we want R and theta?
Draw a triangle.
Draw a triangle, absolutely. Draw a picture. The Pythagorean theorem gives you R, right? That's easy. Does everybody recognize this is a 45-degree angle? However, is theta 45? No. Theta is 315. Done. Do it again with the ordered pair, -2, -2, or 3. So what do we do? Same thing we just did. It's the same problem. So what do we do? Draw a picture. Pythagorean theorem would say 4.
And that's a 36 degree.
That's a 60-degree angle because it's across from the root 3, right? But theta is not 60. Theta is 240. Now this is a trick problem though. This one's tricky. Did you catch R less than 0? We talked about this, but only one day. So you may have forgotten about this. R can be negative. Remember that conversation we had one day? R can be negative. So for whatever reason in this problem, we want a -4. The radius was 4. You got that from the picture. Everything was perfect. This is the right answer. But that has a positive R. The problem says we want a -R. It's just arbitrary. It just says that. So I have to do this. I would never do that otherwise. Never. But because it says, I'm doing it. Now, what happens to the angle? Backs it up by 180. That's exactly right. It changes it by 180. So the original angle was 240. We're going to back it up by 180, so it will be 60. These 2 points are plotted in exactly the same place. They are the same point. Remember, when your radius is negative, the angle is plotted exactly 180 degrees different. So that would put you on 240. So, this one, that was number 2. Number 2 said leave R positive. So we just stopped here. But what if it said make R negative? What would the negative R be for problem number 2 if we had to do that? Negative root 2. And then what would your angle be? 135. Because when you change the sign on R, your angle changes by 180. Opposite side of the circle, 180 degrees difference. All right, convert to standard form. What does that mean?
X plus I.
X plus yi. So this is what I'm starting with, and I'm converting it to x plus yi. Which means basically, what do I need to find, guys?
X and Y.
I need to find x and y. And how do I find x and y? X equals r cosine theta, so x equals 3 cosine 50. Is that 150? Yeah.
That is 150.
And y equals 3 sine 150.
This is 4.
Yeah.
This is special one.
On the last problem, how'd you get the 4?
It's the radius.
What's 2 squared?
4.
What's 2 squared?
4.
What's root 3 squared?
It's 3.
So that makes 12. What's 4 plus 12?
16.
And the square root of 16 is?
4. Okay.
Pythagorean theorem. R is always the Pythagorean theorem. Okay.
Oh, there's special one.
Is 150 special?
Yeah.
Yep. So I'm doing it exact. What's the angle? It's a 30.
Yeah.
Now, be careful, anything negative. Okay, so now we just plug in. So what's the cosine? Adjacent over hypotenuse. So x will be negative 3 root 3 over 2. What's the sine? 1/2. So plus 3/2 sine. I just write my answer as whatever my x plus yi is. Number 5, convert to a polar equation. Okay, what does that mean?
It's the R cis.
No, that's polar form or trigonometric form. A polar equation is simply an equation that has what variables? R and theta. So the equation that you have has x's and y's. So that would be a rectangular equation. We need it to be a polar equation. So what does x equal? What does x equal?
Cosine.
What did we memorize x equals?
R cosine theta.
R cosine theta. So I'm going to take out the x and write r cosine theta. What does y equal?
Sine cosine theta.
R sine theta. Kids, if you don't have those memorized yet, I don't know what to say. Get them memorized. X equals R cosine. It should always be on the tip of your tongue. We use it all the time. Now, look at that equation. What are the variables in that equation?
R and theta.
Is that what we were supposed to do?
Yeah.
We're done. Now we need a rectangular equation. these are a little harder. What is secant theta by definition? What's the definition of secant? R over what? Well, it's a reciprocal of cosine. What's the definition of cosine? X over R. So what would secant be?
R over X.
R over X. That's my thought process too, Teresa. I don't have secant memorized, but I know it's a reciprocal of cosine. All right, anybody remember what we did next? We did several of these one day, but again, it was only one day we did these. You may have forgotten. We got rid of the fractions.
Multiply everything by X.
So we multiplied by X. And then, in this particular problem, we were able to divide both sides by R and end up with just X equals 3. Is that a rectangular equation? Yep. Now we're going to do it again. Same exact problem, kids. How are you going to start? Substitute in
Y over X.
Y over what?
R.
Y over R. And then what?
Or multiply.
What do we do here? Times by R. Now it's a little different. Didn't work out quite the way the other one did.
Divide by an
Tell me about R squared. I was just talking to Zach about it. X squared plus Y squared is the Pythagorean theorem. X squared plus Y squared is R squared. That's how we found R, right? That's how we always find R. We do the Pythagorean theorem. Is that a rectangular equation? Yep, so we're done. Convert to trigonometric form. What do we mean by trigonometric form?
Is that the
What?
Don't you have to replace? Don't you have to put 10 in there?
Well, what's trigonometric form? This.
Oh, yeah.
This is trigonometric form. So we have negative root 3 plus I.
So it's X and Y.
That's X and Y. And we need R and theta. Okay, well, we've done this a lot. What's R?
That's 30, 60, 90.
Well, yeah, it's a 30, 60, 90 triangle. This is a 30.
So it's 150.
Does that be 60? So theta is
150.
150, and what's R? 2. So 2 CIS 150. That's your polar form or your trigonometric form. That's all there is to it, kids. All right, number 9. How do we multiply, that's a multiply problem. How do we multiply numbers in polar form? What is our rule?
Double.
No, double.
Multiply the R's and add the angles.
Multiply the R's and add the angles. So if I multiply my R's, I get 12. And if I add my angles, I get 82. Right? Now I'm going to divide. I'll get Z sub 2 over Z sub 1. I got to pay attention to that. It's 2 over 1. So here we go. What would 2 over 1 be? 4 over 3. 62. When we divide the r's and subtract the angles. What does this mean?
Magnitude.
Which always in a polar form number, the magnitude is just r. So for z sub 1, that would be 3. And what does this mean? The conjugate. And how do we find the conjugate of a number in polar form? What about r? Same. So this is z sub 2, so that we said before. And what about the angle? Make it negative. So that would be negative 72. And then what? What do we know about negative angles in polar form? Can't have them. So we'll rewrite that as 4 CIS. Yeah. Which would be what? 288 maybe? Double check my arithmetic.
Thank you, God. So the R is always the same?
Yep. Number 10. Find the cube roots of 4 root 2 plus 4 root 2i. What does it mean to find the cube roots?
Third power, or 1/3.
1/3 power.
So we want to put it in table 4.
Yeah. So we're going to change it to polar form, which means we need to find what? R and theta. So we do that by drawing a picture, right?
45.
You can tell that's a 45.
Be 8.
8. And we're raising it to the 1/3 power. Okay, so how does that work? How do we raise a number to the 1/3 power? Brittany? Which would be what? What's 8 to the 1/3? 2. And then times a third, which would be 15. So there's answer number 1. Why do I say answer number 1? Because there are 3. Why are there 3? Because root problems have more than one answer. And cube root problems have 3. 4th root problems have 4, square root problems have 2, and so on. Now, how do I find the other 2? They will have the same R value. They're spokes of a wheel. Their length is going to be the same.
Add 120.
Add 120. And you added 120, Robert, because?
It's 180 divided, 360 divided by 3.
Yep. That's how far apart the answers are. If there are 3 of them, they'll be 120 degrees apart. Now, this problem did not give me any directions as to how to write my answer. What form is this? Polar. So on the test, it will say, answer in polar form, you're done, or answer in complex form, which means you have to do what?
Put it back into.
Find x and y for all 3 of these. So we'll do one of them.
It'd just be people.
So if we were going to change that,
2 cosine.
x equals 2 cosine 15, and I would type that in on my calculator. 2 sine 15, I would type that in on my calculator. And then I would write my answer as this plus this I. That's what complex form is. X plus yi. So 1.93. 0.52. All right, number 11.
This is cool.
Yeah.
If it's like, say if it's like 2 kiss 150, since it's like a special angle, you have to
Yep.
put it in that form.
Yep, you have to answer exactly when possible.
Okay.
All right, so here we go. What do we do? Yeah, we need to figure out R and theta, right? So what about R? 4. There's a root 3. So this would be 60. So theta would be
120.
so 4 CIS 120 raised to the 4th power. Okay, how do we do that? How do we raise it to the 4th power? 4 to the 4th, 256, I think. And then 120 times 4, which is too big, so I'll shrink that down. There's my answer if I'm allowed to leave it in polar form. What if it says answer in complex form?
Same thing you just did last time.
I have to find x and y. And how do I find x? R cosine theta, y is r sine theta. And that's just going to depend totally on what the directions say. All right, name the classical curves.
A rose.
Rose,
Spiral.
spiral,
Limousin.
limousin,
Lemniscate.
lemniscate. There they are. Plot the following points and label them. You got some graph paper. All right, so here we go. We'll label these. 3, 120. Circle with a radius of 3. There's 1, 2, 3 on the angle 120. Easy. 4, 5 pi over 4. Well, that one's in radians, but it's equally easy. What might you want to do? Change it to degrees. How do we change it to degrees? What's pi? 180.
Divided by 4.
What's 180 divided by 4?
45.
Times 5. 225. So here we are at 225. And what was my radius? 4. So there's that one.
So wait, how did you get that to degrees?
Pi is 180. I divided by 4 would be 45, times 5 is 225. 2 negative 15. This would be negative 15. So there it is, 2 negative 15. Negative angles mean you just go down, just like always. What about negative 2, negative 30? This is a problem. You gotta make it positive. You can't, there's no negative radius on that circle. So we gotta make it positive.
And then you add 180.
Yep. And so that gets plotted at 2 comma 150. When you change the sign on R, your angle changes by 180 degrees. Graph on the calculator. Okay, I'm gonna have you do this on your own, but before, you should tell me what A is going to be. You should recognize what A is going to be. What shape? That's gonna be a rose. What is B going to be? A limacon. Will that limacon be a cardioid?
Yes.
No.
No.
Why not? Because you got a 2 and a 3, right? Not a 2 and a 2 or a 3 and a 3. So when you graph those, I have graphed them on the back, so you should end up with those same pictures when you graph those. Okay? Now, in the coming days, you have another pretest to do, right? I gave it to you as a separate page, because I wrote it separately, made it new. It's a separate page I gave you. It's called pretest number 2. In addition, in your packet, you have something called in-class review, or review in class. It's in your packet. And the answers are all worked out on the back. Okay? So here's what you're going to be doing in the next couple of days. Tuesday and Wednesday, you will be working on the in-class review and pretest number 2. Right? You have each other as resources. We have just gone through entire problem by problem pretest number 1. Pretest number 2 is it matches it exactly. Or order's different, but problems are the same. And then you got an in-class review sheet, which is the same material, and the answers are provided on the back, the worked out solutions. So between all of you, you should be able to figure that out. That's how you're spending Tuesday and Wednesday. And then Thursday, you're gonna come in and you're gonna take the test, and you're gonna knock my socks off with how well you do. I'm gonna grade it. Okay? So if I'm sitting in the hospital on Friday, depressed because you sucked on the test, it's going to be totally on you. I'm going to be so disappointed. I want to be happy on Friday because you all got good grades, right? You should. Dan?
Is the test gonna be over the first half of chapter?
No, the test is 6-4 to 6-6. It's exactly what we just did.
Okay, I can do it.
It's exactly what we just did.
First half is 6.